Hello viewers, welcome to my channel. I'm Hashim. Now I'm going to start the problems on chi-square test. Previous video I have explained you the meaning, the theory part of this chi-square test. So in sampling we have different types of tests like parametric, non-parametric. So we have done so many tests regarding z-test, t-test and ANOVA. All these things we have done. Now we have started this new topic called chi-square test. So before learning about the problems of chi-square test, I suggest you be thorough about the theory. Without understanding the theory, it will be difficult for you to understand the problems. So last video in detail I have explained. So actually chi-square test is a test, it's a non-parametric test which is applied to test a set of two frequencies. One observed frequency, another expected frequency. Whether there is significant difference between this observed frequency and expected frequency or not. For finding out that, we have to apply chi-square test. For complete detail, go to the playlist of my channel, select the subject statistics for management. Select the video of chi-square test theory. Be perfect, then you come to the problem. So before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always you have to keep ready the problem. Take the screenshot of the points which I have written on the board, then I'll explain. Come on, see the first problem. The following is the result of a survey regarding employment and literacy. So two attributes are given, one employment, another literacy. We want to find out whether there is any association between employment and literacy. So we have taken the data, observed frequency, literate, employed, 400. So actually we have taken a sample of 1000 people. In that 1000 people, literate and employed. That means they are employed and they are literate, 400 people. And literate, unemployed, 100. Illiterate, employed, 300. And illiterate, unemployed is 200. These frequencies which are given is the actual frequency. Now it is asking you construct a 2 by 2 contingency table. 2 by 2 contingency table means 2 rows and 2 columns. So one attribute we will take in rows, another attribute we take it in columns. Then and apply the chi-square test to determine whether there is any association between literacy and employment at 5% level of significance. That is the problem. Now two attributes are given, literacy and employment. First of all, we have to make a null hypothesis. Null means no difference. N-U-L-L. The meaning of null is no difference. So there is no association between literacy and employment. And the alternative hypothesis, yes, there is association between literacy and employment. So after conducting the test, we will come to the conclusion whether null hypothesis should be accepted or alternative hypothesis should be accepted. That is our concern, right? So how to proceed for the answer for this problem? See carefully. HO is the symbol for null hypothesis. And null hypothesis says, let us frame the null hypothesis, there is no association between literacy and employment. Whenever we make a test, chi-square test, always the null hypothesis should be taken as no association between the two attributes. So alternative hypothesis will be opposite to this. Opposite means there is association between literacy and employment. Level of significance 5% given. Now observe the frequency. I have constructed a 2 by 2 contingency table. Here we have taken in columns employment, unemployment. In rows literacy, illiteracy. Why I have taken like this? Because we want to find out the association between literacy and employment. So first literacy I have taken, here I have taken employment. That is the reason why first row literacy, first column employed. So employed, unemployed, literate, illiterate. And the data is given in the problem. In the problem it is saying literate, employed. So this is literate and this is employed. How many people are given? 400. So I have taken 400 here. Right? Similarly, literate, unemployed. So this is literate and this is unemployed, 100 people. Then illiterate, employed. So this is illiterate, this is employed, 300. And lastly, illiterate, unemployed. So this is illiterate, this is unemployed, 200. So these 400, 100, 300, 200 are given in the problem. Now take the total of the columns and rows. 400 plus 300, 700. And 100 plus 200, 300. 400 plus 100, 500. 300 plus 200, 500. This table is called observed frequency table. And an actual frequency table which is given. That's all. Now we have to find out the expected frequency table. Expected frequencies. So how to calculate expected frequency? One formula is there. Row total into column total divided by grand total. This is the row total 500 and this is the column total 700. So we have to multiply the row total 500 into 700 divided by 1000. Grand total is 1000. Why we call it as grand total? Because it is a total of column and also it is a total of rows. So grand total 1000. So 500 is the row total, 700 is the column total. 500 into 700 divided by 1000. We'll get expected frequency, right? Now the expected frequency table will look like this. Now same table, rows and columns same. Now values will change. I want this literate and employed. So we have to multiply 500 into 700 divided by 1000. You will get 350. Similarly 500 into 700 divided by 1000, you will get 350. Here row total is 500. 500 into 300 divided by 1000, you will get 150. Similarly 500 into 300 divided by 1000, you will get 150. Now you take the total 350 plus 350 is 700, 150 plus 150 300. And here 350 plus 150 500, 350 plus 150 500. That's all. We have calculated the expected frequencies with the help of observed frequencies. That's it. Now applying chi-square test. In chi-square, we have the formula O minus E whole square divided by E. That is the formula for finding out computed value of chi-square. This I have already explained in the theory video, right? Now, first column O. O stands for observed frequencies. E stands for expected frequency. O minus E, we have to find out the difference. O minus E, square the difference. O minus E whole square. After squaring, divided by E, divided by expected frequency. The observed frequencies are 400, 100, 300, 200. So 400, 100, 300, 200. Like this, row wise I have taken. Same row wise I have to take for expected frequency. 350, 150, 350, 150. So here 350, 150, 350, 150. Now O minus E. 400 minus 350 is 50. 100 minus 150 is minus 50. 300 minus 350 minus 50. 200 minus 150 is 50. This is O minus E. Now square this O minus E. So 50 into 50. Squaring 2500. Similarly 50 into 50. Minus into minus will become plus. When you square minus, it will become plus. So 50 into 50, 2500. Here also 50 into 50, 2500. Same. Now O minus E whole square divided by E. So this 2500 divided by 350, you will get 7.14. Similarly 2500 divided by 150, you will get 16.67. 2500 divided by 350, 7.14. 2500 divided by 150, 16.67. Take the total of this O minus E whole square divided by E. You will get 47.62. 47.62. We have computed value of chi-square. Now we write down There are 6 steps in testing the hypothesis. The first step is laying down of null hypothesis and alternative hypothesis. The null hypothesis, there is no association between literacy and employment. No relationship at all. The employed people may be literate or illiterate, right? The unemployed people may be literate or illiterate. There is no association. That is the null hypothesis. Always you have to make like this. Then alternative hypothesis, yes, there is association between literacy and employment. There is some relationship. That is the alternative hypothesis. So this first step, laying down of hypothesis. Second step, level of significance. That will be given in the problem. Level of significance means what is the risk you are taking in this chi-square test. It is not 100% correct. 100% accuracy will not be there. So how much risk you are taking, that is level of significance. Normally it will be 1%, 2% or 5%. So if nothing is given, we take 5%. But in our problem, 5% is given. So level of significance alpha is equal to 0.05. Now degree of freedom. It is abbreviated. The symbol is V. V is equal to C minus 1 into R minus 1. C stands for column, R stands for rows. So how many rows and how many columns do you have? 2 rows and 2 columns. So in place of C, 2. In place of R, 2. 2 rows, 2 columns. 2 by 2 contingency table. So 2 minus 1 is 1, 2 minus 1 is 1. 1 into 1 is 1. So degree of freedom is 1. Now test statistic. That means here we have to compute the chi-square value. Already we have computed here in this table, we have computed 47.62. This is the computed value of chi-square. Now critical value. For critical value, we have to refer the table. In every textbook, the chi-square table values will be given. For your benefit, I have given a PDF of this chi-square table in the description. So along with the problems, take the printout of table value of chi-square. It will be provided in the examination, or else the value will be specified in the problem itself. So don't worry, you don't need to remember all these values. Now, the table value. In the table value, in the rows we are given degree of freedom. You can see the table. In the rows we are given degree of freedom. In the columns we are given level of significance. So we are having 5%. 5% means 0.05. So under 0.05 against 1. In the row 1 against 0.05 you will get 3.841. So 3.8481, sorry. 841 or 481? It is 841. 3.841. 841. This is the table value or critical value of chi-square. For 1 degree of freedom at 5% level. Now decision. Now we have 2 values. One computed value, one critical value. Computed value is 47.62 and critical value is 3.841. So how to take the decision? If the computed value is greater than critical value, it falls in rejection region. Whenever the computed value is more than the critical value, it means it falls in rejection region. The null hypothesis is rejected. What is the null hypothesis we have framed? There is no association between literacy and foundation. That we are rejecting. If we reject null hypothesis, we have to accept the alternative hypothesis. The alternative hypothesis says there is a relationship between literacy and employment. So ultimate conclusion, we have rejected the null hypothesis and accepted the alternative hypothesis and make the conclusion there is association. There is association between literacy and employment. Null hypothesis rejected, there is association between literacy and employment. That's all. This is the first problem. So I have explained each and every point in detail. So if you are really interested in learning this subject, statistics for management and each and every problem, watch the video till the end, don't skip in between. So if you take the interest, the learning process will be very much enjoying. Otherwise, simply for the sake of examination point of view, if you are watching, then simply you have to learn the steps mechanically. But I don't think my students are interested only in passing the examination. They want the knowledge. They want the perfection. That's why I'm explaining each and every point in detail. Now, second problem you see. A drug is claimed to be effective in curing cold. One drug is prepared and it is claimed that this drug is beneficial in curing the cold. In an experiment on 164 persons with cold, half of them were given sugar pills and half of them were given drug. The patient's reaction to the treatment are recorded in the following table. Now, a pharmaceutical company, they have prepared one medicine for curing cold. And they want to find out whether this medicine is effective in curing cold or not. So they have selected a sample of persons. 164 persons they have selected. Out of 164, half will be given sugar pill and half will be given drug. All the 164 people are suffering from cold. All 164 people suffering from cold. So 82 people were given drug and 82 people were given sugar pill. Now we want to see the effect. After giving drug and after giving sugar pill, what is the effect? What is the effect in curing the cold? That we have analyzed. And the table it is given. Helped, harmed, no effect, total. For drug, when drug is given to 82 people, 52 helped. Helped means the cold was cured. And 10 harmed. That means after giving the drug, the cold has increased. And 20 people, no effect at all. After taking the drug also, no effect in curing cold. Similarly, sugar pill. 82 people were given sugar pill, 44 were helped. Even by taking sugar pill, the cold was cured. Then 12 people harmed. After taking the sugar pill, 12 people harmed, or this cold has increased, and 26 people, no effect at all. This is the observed frequency given in the problem. Now the total 52 plus 44, 96, 10 plus 12, 22, 20 plus 26, 46. Row wise 52, 10, 20, 82, 44, 12, 26, 82. This is called observed frequency table. Now we need to calculate expected frequency table. I have given the formula: row total into column total divided by grand total. So first of all, what you have to do, the same totals what is given in the observed frequency table, same totals you take it. For example, 96, 22, 46. Here also you take 92, 96, 22, 46. Total 164. 82, 82. Same. Whatever in observed frequency, take the same totals, right? After this, you take the total of the row into total of the column divided by grand total. For example, I need this 48. How do we get this 48? Row total 82, column total 96. So 82 into 96 divided by 164, you will get 48. Similarly, here also row total is 82, column total 96. So 82 into 96 divided by 164, 48. Here the row total is 82, column total 22. So 82 into 22 by 164, 11. Similarly, 82 into 22 by 164, 11. Here row total 82, column total 46. So 82 into 46 by 164, 23. Similarly, 82 into 46 by 164, that's all. So we have calculated the expected frequency also. Now we need to find out the computed value of chi-square. So we need O, observed frequency, E, expected frequency, O minus E whole square, and O minus E whole square by E, right? Observed frequency here, row wise you take 52, 10, 20, 44, 12, 26. So here 52, 10, 20, 44, 12, 26. Column here also 48, 11, 23, 48, 11, 23, 48, 11, 23, 48, 11, 23. That's all. Now O minus E. So 52 minus 48 is 4. Right? 10 minus 11 is minus 1. 20 minus 23 minus 3. 44 minus 48 minus 4. 12 minus 11 1. 26 minus 23 3. So we have taken the difference. Now square it. 4 4s are 16. 1 1s are 1. 3 3s are 9. 4 4s are 16. 1 1s are 1. 3 3s are 9. Now after squaring, divide it by E. So 16 divided by 48, you will get 0.33. 1 divided by 11, you will get 0.09. 9 divided by 23, you will get 0.39. 16 divided by 48, you will get 0.33. 1 divided by 11, you will get 0.09. 9 divided by 23, you will get 0.39. Take the total 1.62. This 1.62 is called the computed value of chi-square. Calculated value of chi-square. Now we'll write on the steps. The first step, null hypothesis. There is no association between drug and sugar pill. In other words, the drug is not effective in treating cold, in curing cold. There is no effect at all. Whether you give the drug or do not give the drug, the cold will be cured. That means drug is not effective in curing cold. That is the null hypothesis. Alternative hypothesis, yes, drug is better than sugar pill. That means drug is better in curing the cold. That is the null and alternative hypothesis. Now level of significance, alpha is equal to 0.05. I have taken 0.05 because in the problem it is not given. So you can take 1% or you can take 2% or 5% if it is not given in the problem. So here assumed. Degree of freedom, C minus 1 into R minus 1. C stands for columns. R stands for rows. So here columns are 3. 1, 2, 3 columns. And rows are 2. So in place of C, 3. In place of R, 2. 3 minus 1, 2. 2 minus 1, 1. So V is equal to 2. Degree of freedom, V is equal to 2. Now test statistic, computed value of chi-square, already we got it 1.62. Critical value. Now you have to refer the table. In this table, for 2 degree of freedom, so in the row 2, under the column 0.05, under the column 0.05, you will get 5.991. The value is 5.991. So here 5.991 also you write it down. 5.991. This is the table value or computed value. Now decision, final decision. Compare the computed value with the critical value. Computed value is 1.62. Critical value is 5.991. In other words, the computed value is less than the critical value. In the previous first problem, the computed value was greater than critical value. So it falls in rejection region. But here computed value is less than the critical value. So it falls in acceptance region. So in the decision you should write down the computed value of chi-square 1.62 is less than the critical value 5.991. So it falls in acceptance region. We accept the null hypothesis. We accept the null hypothesis. What the null hypothesis says? Drug is no better than sugar pill. That means drug is not effective in curing cold. That's it. The drug is not effective in curing cold. Null hypothesis we have accepted. Why we have accepted? Because the computed value is less than the critical value. That's it. So first 2 problems I have explained in complete detail. Remember, simply watching, listening is not enough. Practice yourself. Then only you can get the complete understanding of the concept. You will feel confidence in yourself in understanding and solving the problem. So if you are satisfied, give a like to the video, share my channel among your friends, among your groups so that more students can watch the video and enhance the knowledge. Subscribe my channel if you have not yet subscribed. So inshallah we'll continue the next problem in the next video.